Here we are prompted to choose a design methodology. Okay, we will start with Mixture DOE, sir, Samvit sir.
We can tell them the basics like, okay, let me start a little bit. So
Okay,
when you do design of experiments for QbD or something, then first of all, you don't know which factors are significant. Okay, and this is just a training on how to use the software. We have separate training for concept and all that, which is like 2 days training. So I'll just touch upon little bit of concept and then get into the software part. You can play around, and if you need detailed training, we can discuss that separately. Okay, so what is the design of experiment? Let's start with that. And why do you need to design an experiment? So basically, when you are doing an experiment, your objective is to find some settings or some mixtures, compositions that will give me the desired output. But there are infinite combinations of inputs that are possible. And if I just randomly do things, it will take us a lot of time and we may not reach the optimal solution. So DOE is a statistical method of arriving at your desired output with your with limited number of experiments that you can conduct with limited amount of time and resource that you have. Okay. So when we speak about this, yes. Now when we talk about the inputs and output, inputs are called factors and outputs are called response in statistical language. Okay. So the factors could be anything like temperature, pressure. If you're using an HPLC, then um, the column temperature, any of those things can be a factor that can be influencing my output. Okay. Now, first of all, uh, what happens with increasing number of factors? Let's say we want to do an experiment, and in order to understand the relationship between the factors and the response, you need to do at least two two levels. So for each factor, let's say temperature you set at a low and a high value. Pressure you set at a low and a high value. Some compositions, let's say you are saying that, I will take some extreme set of compositions, right? So you need to define those extremes, which are called levels, okay? Factor levels. So let's say temperature. You can operate your experiment at 23 degrees Celsius to 43 degrees Celsius, let's say. Then 23 and 43 becomes two levels. There could be a third level in between somewhere, but minimum two levels are required. Okay, so these are called levels. Okay, so three things to remember: factors, response, and levels of factors. Okay, so when you have large number of factors, the minimum number of levels you need is two. So 2 to the power k or 2 to the power 2 is the number of levels. 2 to the power k is the number of factors, is the number of experiments that you need to conduct, minimum number of experiments to be conducted to arrive at some meaningful data based on which some mathematical models can be created. Okay, so imagine what is the value of 2 to the power k. If I have one factor, then I need to do only two experiments. If I have two factors, then I need to do 2 multiplied by 2, which is 4 experiments. If I have three factors, then 2 to the power 3 is 8. 2 to the power 5 is 32, then 64. You see how the number of experiments are just doubling with every factor that I'm adding. That means if I have a large number of factors, I cannot determine which factor is important for me. So I will be running unnecessarily huge number of experiments. So that is why what we need to do to begin with is we need to run screening experiments where with minimal number of experiments we will be able to determine the factors that are significant. So screening experiment you should do first. Then depending on the nature of experiment, let's say you are doing a composition, then you go to mixture DOE. If you have no compositions, then you can go for factorial DOE. And for final, when you want to do some kind of refinement, then you go for response surface methodology. So, okay. So, Chaitanya, you can start with the screening design first, and then we
Okay.
can take up the mixer DOE. Sorry? Yeah, Chaitanya, over to you. You can take over from now.
Okay. Let's start with screening design. So here you will have a list of experiments that you will have previously conducted. We'll go and start a new experiment. So you click the button over here and you are led into this form, which needs you to define the properties of this experiment. So we'll start by giving it a name. Any particular name you would like, or should I just continue with a demo name? Continue with the demo name.
Uh, Team, if you can just make it a little interactive, it will be easier for us to understand whether you have understood or not. Okay, just continue.
Okay. First, you start by giving the experiment a name and select a work unit that is associated with the experiment. Now, work units can be configured in the configuration page. We'll get to that later. But
हम देखो साइड में चल रहे हैं
okay. Work units can be configured later, but you need to select a work unit that is associated with the experiment. And then next you move on to factors. Now factors, you will receive a drop down here for already pre-configured factors. But in case you, let's say, want to create a new factor, you can click on this add button over here. So any new factors name would you like to try, or should I go with demo again?
Yeah. Sorry, I'll intervene. Uh, can I get a quick update on the who are the people who are joining? Do you have some basic understanding of DOE?
yes sir we do have
Okay. So can I request you to participate and prompt Chaitanya something instead of we talking in our own language?
sir actually there is some noise coming when I open my mic.
Maybe I think you and your colleagues are all sitting in the same room. So
Okay
if you're all in the one room, then please join from one desktop or laptop only. And others can probably switch their mics and the audio devices off. Yeah. Please participate, team.
Okay.
Yeah.
Any new factors you would like to add for a demo experiment? Any name would suffice, even like distance, pressure, whatever. Okay, I'll go with distance for the time being. And meters. Then after you have named the factor, set the unit and the factor type, you can click on save factor, and this automatically saves this factor and selects this factor for you. Then if you want to add another factor, two factors are obviously necessary. So we'll add another factor, and I'll give this one time.
Okay, sir.
Yeah. I'll give this one time, select the unit as seconds, and the factor type is numeric. We'll save this factor. Now you can add multiple factors here. But for the purpose of the demo, I'll just do this experiment with two factors, and after that we select some bounds for these factors. So this will be the space in which the design will be conducted. Now, any bounds you may want to add? Uh, Simple numeric.
From suppose 4 meter to 10 meters.
Yep, 4 meter to 10 meter.
Okay.
And time would be
15 minutes to 25 minutes.
okay. I had configured it as seconds, but that's fine.
Okay.
I'll just put it as 15 seconds and 25 seconds.
Okay.
Yeah. So after you have configured these low and high values, you select your screening type. So we have these Plackett-Berman definitive screening, fractional, factorial, and D-optimal. Since Plackett-Berman is selected, we can just go with this. Would you like to see any of the others, or should we just go with Plackett-Berman for now?
Go with Plackett-Berman.
Yeah. Run size, I'll keep it as 12.
Okay. We can change
Up
the
to
run size.
Ma'am, the run size will actually depend on the experiment also, but this is the max.
Maximum 12 runs will be there.
Yes, yes. You want to go for 24?
Okay.
Okay. Center points if you want any.
Okay, middle value.
Yes.
For distance, it can
for
be 6,
हाँ,
6 or 7.
For distance, let it be 6.
No, not like that.
Um,
Not like that. You can leave it empty as of now. Yeah.
मतलब,
Okay.
what can we enter into replication and randomization actually?
Ma'am, these are actually center points are actually not, you don't select them. Center point is actually the midpoint of what you have given as low and high. So
Okay.
adding center points would just add in a run that would be a mid value of this of distance mid and time mid. And replicates actually
we
replicate.
ourselves have to enter this, or it will
No,
take
no,
it
ma'am,
automatically.
you just add a center point here. Put one.
Okay, 1. Okay, ठीक है.
And replicates these center points. So these are more
Got it.
used in lack of fit tests, where you can have multiple center points having different values. So that gives the model more precision or shows where it is lacking. So that is how it is used. And random seed actually, so ma'am, these run orders, when you will receive the design, the run orders are actually randomized in order to separate any non-controllable factors. So let's say if maybe sunlight could have been a factor in an experiment. So it is possible that sunlight could be affecting this experiment. So in these cases, when you randomize the run order, the experiment results are more clean than when you do the experiments in the same set of order, because then you will keep experiencing a effect which is not relevant to the experiment. What random seed does is when you give it a number, it is able to replicate the same randomness. So although it is a random format, if you later want to replicate a design with the same run set, you just have to give it the same random seed run number, and that will give you the same random seeds, same run same run order. So that is how it works. I'll keep this 0 for now. And you generate the design. Now you see 24 runs are generated.
Okay.
Since we had clicked on the Plackett-Berman 24 runs. Now, once you generate design, this actually this is just a design preview. This has not been saved yet. And if you want to change some stuff even now, you are freely able to do so. If we were to, let's say, make this 15, then generate the design again. This would again change these this would change these run orders again. And until and unless you find that, okay, this runs look good, we want to proceed with this, then you just check this, what has come here. If you think it's fine, you click on Save Design and proceed. So once you click on this button and save the design, this will actually bring you over to this page, which is the experiment detail page. Now your design has been completely saved and you can perform these experiments. The first order of business here is to add outcomes. So when you are actually when you're actually doing the experiments, you will be measuring something, right? So you just click on this plus outcome button. This actually will create an outcome column for you. Now this is the area where you will actually be able to record and store the experiments. Double clicking on this response column, this will actually allow you to change the name of the column. So I'll just put it as speed since we are already doing distance and time, and rename. Now let me save this. Now once these runs are actually saved, hold on. These columns are actually saved. Now, what you can do is whenever you have completed an experiment, let's say you have completed the experiment which concerns distance as 4 meters and time as 15 seconds. You found that speed was 30. So you record these experiments in here itself, right? So maybe 30 and this is the same point. So we will put it maybe 31. Then 32. So like this, you can keep recording your experiments here. 34, 35. So this is how you will, and it does not need to be full in one shot. You can, if you have just done 4 experiments, 5 experiments for the day, you can just save those. And clicking on save will log those experiment results, and you can change them later as well. So this will log these experiment results in. And after this, you can keep performing experiments. Now, now once you have actually fully performed all the experiments, you can proceed for analysis. Just let me check once if we have completed experiments. This seems to be completed, right? Ma'am, I'm just switching over to experiment that has already been completed because we would have to fill out all the responses first for this experiment to be analyzed. So I'm just switching over to a one that has already been done. I'll just show you what happened there. So I'll move over to this EXP2. So this had actually 3 factors and we had recorded 1 response variable. So you see here, these responses have already been filled up, all of them.
Excuse me, sir.
Yeah.
Can we have more than one response?
Yes, you can have multiple responses now.
So each time we have to click the button outcome.
Yes, that's exactly right. So you can click on this multiple times. You can add as many responses as you like.
Okay.
And one analysis actually analyzes it for every response, and you will get them as different radio buttons. I'll just show it to you. But let's first, I'll just show you the analysis, how it works. So let's say for this example only, we have only 1 response, right? You have recorded all the results. Now what you have to do to analyze all these designs is to click on what runs you actually want to analyze. Now the core rule here is to at least analyze the number of runs that were given to you in the original design, which is 12. Now, why I say this is because we also provide to you a functionality of being able to add manual runs. So let's say you had made some other runs you had made some other runs that you had made prior to actually designing this experiment, and you want to keep them for record as well. So I would put you just add this manual run column row, and then you just add whatever you had done to for this design. Let's say I had actually got it at 20.6, 30.25, 45. And this has come out as 34. So we also give you the functionality to be able to manually add runs. So click on save. And you can also analyze this run as well instead of some other run, or you can analyze all the runs. But the core rule here is that at least the number of runs that were provided to you by the software. So in this case, 12 here, or in the case we were creating before 24, at least that many runs need to be analyzed. So you need to analyze at least 12. At least 12 here. You can also analyze the 13th one. So now after you have selected all these runs that you want to go for analysis with, you click on this, you can click on this analyze button if OLS looks right, but we also have other different analysis modes. So OLS, stepwise, and LASSO analysis. So you can select any analysis mode you actually want to analyze your runs with. So we'll go with OLS for now, and click on this analyze button. What this now gives you is the frozen run set, right? So why this frozen run set is important is that we can actually change these values later on. So if I were to add, let's say, another manual run, or maybe change the generated design a little bit, it would be confusing for a analyst later on, because what would happen is they would see the runs, current live runs, and look at the analysis saying that this is not matching. But what happens in this case is that whatever runs that actually you use to perform the analysis are stored with that analysis. So even if you change the runs later on, these do not reflect here. This is like a frozen run set that you had used for that analysis, right? So you can see this run set that was used for the analysis. Next, you can see the R square, adjusted R square, predicted R square, MSC, CV percentage, and how many runs that were used for this analysis. Then the regression equation in coded units with the regression equation here. And then you have the model coefficients, and you have the ANOVA table. Then after that, you can also see the regression equation in natural units. So there are two ways. One is the coded space of regression equation and the natural unit regression equation, right? Then next you have a list of plots, the Pareto of effects. You can choose to render whichever plots you wish to. Normal probability, then residual versus fitted, normal Q and Q, then histogram, and residual versus observation order. You also have different sets of visualization, that is the main effects, and you have interaction effects as well. So there were no interactions for a Plackett-Berman 12 run. That is why it will not give you any interaction data. but just in case you have it in a different design, you will be able to see interaction plots as well. Next in the same flow, you get the what if analysis. Now, what this is a prediction. You can actually predict based on the current model that was trained. You can actually predict what is the value of a response based on inputs you give. So by default, it selects midpoint inputs for you, but these can be changed, right? So after you change these and select them, you can add rows as well to see multiple outputs, what they should be at once. Then you click on predict. What predict does is based on the inputs you have given, what should be the output on the model that you have trained. So based on this model right here, you would get a predicted outcome of 24.7608. Then you have the CI 95% confidence interval low, 95% confidence interval high, then 95% PI low and 95% PI high as well as a response of this. You can add multiple rows into this and you can view multiple outcomes at once. Now the reverse of this, let's say you want to view specifications based on a particular response. So for that you would go for optimization analysis. What this does is it allows you to hit targets, maximize or minimize targets, and gives you a set of solutions of inputs such that you would accomplish your goal of maximizing, minimizing, or hitting the target response. So an example of this I'll show you. So I've clicked on the goal as target, and we will go for a target as maybe the same thing, 24.7, 24.8. Lower limit of 20 and 30 upper limit. And once you have set all these values and click on optimize over here, you will actually get a solution set of all values, all inputs that will lead you to a predicted response of 24.8 or whatever you have set into target. You can also choose to double click and choose to maximize, minimize, which would actually pull you toward the lower limit or pull you toward the upper limit. But that's how this would work. And you can see all these solutions set here with composite desirability as one. So these inputs would actually predicted lead you to a particular response. So this is how you would check specifications. We also have another feature of AI where you can ask AI questions on this particular analysis.
बहुत बढ़िया.
So you see here, these analysis will be provided as context to the AI, and it will be able to answer whatever questions you have. And let's say you want to compare, you want to see that model fit, it was this. So you can just pop this AI feature out and then just scroll through your entire analysis while being able to ask AI questions intermittently, right? So that would conclude screening. Next, should we go for DOE, mixture DOE, sir?
Okay.
You can,
सर एक्सक्यूज मी
yeah,
सर, ये जो
yeah, yeah, yeah.
ग्राफ्स आए हैं इनको हम डाउनलोड वगैरह कर सकते हैं अगर हमें अपने पेपर में या थीसिस में अगर करने हो पेस्ट.
Right. Currently, that feature is only available. These graphs actually can't be downloaded. So if you would like us to add that as a feature, we would be able to do so, but currently that feature does not exist.
So हम डेटा कैसे यहाँ से
एक्सट्रैक्ट करेंगे, मतलब इस ग्राफ को फिर कैसे एक्सट्रैक्ट करें?
Maybe so more graphs actually are can't be extracted in itself. You can extract these data by right clicking on all of them and clicking on the export button.
बट जैसे बॉक्स बैकएंड के डिजाइन्स होते हैं, जो रेस्पॉन्स सरफेस डिजाइन्स हैं या टगुची के जो ग्राफ्स है, अगर हम उन्हें शो नहीं करेंगे तो फिर फायदा नहीं होगा ना डिजाइन लगाने का. एंड सेकेंडली एडिटिंग कर सकते हैं कि नहीं कर सकते ग्राफ में?
Sorry.
ग्राफ्स में एडिटिंग कर सकते हैं, जैसे मान लो समटाइम्स होता है कि बोलते हैं यूनिट लिखो या कोई एक्स एक्सिस पे क्या है, वाई एक्सिस पे क्या है, तो हमेशा नहीं होता, कभी कभी नहीं होता, तो वो हम एडिटिंग कर सकते हैं ग्राफ्स में.
So some graphs which allow editing, those are present in the ये अभी इसमें इस वाले में कोई ऐसे graphs नहीं है. So by editing, do you mean like कि let's say contour plot में you want to keep some values at hold? Do you mean something like that?
Like
नहीं, simply labeling purposes से.
Okay, so changing the axis and things like that.
Labeling units.
Yes. That is possible in some other graphs. These graphs don't have any axis as such. So let me show you a graph that will allow this. This is actually available in Mixture DOE. So things like resolution. So you can put in, although for mixture designs, if this is a three chemical mixture. So you can actually do the same thing here. You see these x-axis and y-axis and resolution columns, right? These drop downs. So you can actually change axis for a three mixture design. It's not applicable because what happens in a three mixture design is, since mixture space is constant, so it is one. So in a three mixture design, if you put x-axis as something as y-axis as something, it automatically resolves the z-axis as the third chemical. But however, if you have like four or more chemicals, you would get another option of z-axis, which would allow you to control each axis of the, let's say you want to see only chemical 2, chemical 3 and chemical 5 relation or contour plot. So you are able to do that. You can also, if there are some process parameters for that experiment, you can also put those values on hold. So those are possible. You also get a 3D surface. And this is really pertaining to Mixture DOE. Now, a lot of graphs, Mixture DOE, most graphs will have the option to be able to select the axis and what hold values you should give for them. But a lot of normal graphs will not have that feature.
Okay. सर ये कंटूर प्लॉट है, जैसे इसको हम डाउनलोड कर पाएंगे या नहीं?
You can save
Copy image.
this image. Yeah, you can save the image of the, because this is a technically image, तो वो image save हो सकता है. This is as PNG. तो ये image save हो सकता है, but that is from downloading perspective, that is the what you can do. So just right clicking on the graph itself, you can just save image, and that will save whatever plot has been given as a PNG.
ठीक है.
So yeah. Next, so I was getting into Mixture DOE. So after you have done screening design and you have an idea of what factors are relevant, you can go for either Factorial or Mixture DOE. Let's start with the Mixture DOE thing. So what you can just go for designing a new experiment, and then we also in Mixture DOE you also have the feature for cloning the design of a previous experiment. For now, we will go with just a new experiment. Again, you just give the experiment a particular name. So let's say test June 1. And you can select whatever work unit this experiment is associated with. उसके बाद in a mixture design, you have to mention what is the total mixture. Now by default, this is 1. But you can set up any mixture total you wish. So it could be a 100, 100 could be a mixture total, it could be 250, 1000. So anything you can set up as mixture total. But this is what the software will use as reference to actually calculate the total of what the mixture computes to. So if you have 3 factors, 3 components, the adding all 3 components should equate to 100. So you will have to set it up like that. So if you're measuring in 250 ml. So maybe you'll have to use a mixture total as 250, right? So we'll put it as 100 for now. Then after that, you will have to select components. What components you want to use. Now, this is the same thing as how I showed you in screening. If you don't already have a component configured, you will just click on this add icon over here, and you can click and you can configure a component right from here. So maybe CaCO3 could be a component with mg here, and you save the factor. So this automatically selects this factor. Then again, you will already have you can't select CO3 again. So if it's already not there, the second factor, again you can just choose to add. So maybe NO2. G. So you can add multiple factors over here, and once the factors are added, you can select whatever you want from the drop down. Right. So you add in the factors, add in the components, and again, if you want to add multiple components, you just click on these add component button, and you can add as many as you like, up to 7. But we'll use 2 for this session, this demo. And after that, you have to, for each component you have selected, you will have to okay. You will have to select what bounds you want these components to work within. So let's say you want CaCO3 to always be greater than or equal to 20 mg, but it should never exceed 80 mg. Similarly, you want nitrogen to never be less than 10, and it can go up to 90 or 95. So you'll have to put in the component bounds here, as in what component should operate within what range, right? And then you can see here, once the constants are detected within this design space, automatically the software will recommend extreme vertices as the design type. But for any unconstrained space, so you would be able to use simplex lattice, simplex centroid, extreme vertices, any of them. Then next you will have to add process variables if needed, obviously. So again you can add process variables. So yeah, if you remember, I had just created distance and time from a previous project. These are carried over. So let's say you had put in added a factor distance in screening. This will be also available for use in all other DOE methodologies, right? So since we had added distance and time, it's already available here, but we want to go for a different component which is not available here. So again, you just click on this plus icon, and we'll go for temperature of Celsius. So you just select whatever you want for the new factor, which will be a process factor, and then you just save the factor. Now the factor will be automatically selected. You can add more factors again. I'll add one more. Maybe we can add pressure of PSI, and again saving the factor. And now the factors are selected. You will again move to the same bounds. Now these are by default in coded space, which is -1 and 1, but you can define them in natural space also. So maybe you want the temperature to be within 100 and 200, and the pressure should be between 300 and 500. So you can define the bounds of these process variables, right? And after that, you will be able to select the available factorial designs. Now, for two process variables, the available factorial
Chaitanya,
design is
just
only full.
explain them. Chaitanya, can you explain them the constraint in the mixture, like infeasible mixtures and all that? Some are infeasible, no? Just show them that.
Right, right. So there are again multiple constraints while you create a mixture design. So let's say the highest amount you gave for CaCO3 is maybe 40, and the highest amount you gave for NO2 is also 40. What this will show you is it is an infeasible mixture. The reason for this is that the design space in which you have set the components, which is 40 and 40 high, even with the highest value used, this would never actually be equal to the mixture total. So these are infeasible mixtures. In these cases, you cannot generate a design. So the design must respect possible boundaries. Obviously, it will be mentioned to you by the software. If you decrease the limit, obviously this will reset. If you put it as 80, it will be again normal. But since this was 100, this will not be a feasible mixture. So,
Sir, here we have
so
two values. One is low and the other one is high. Can we also
yes,
keep a medium value here?
medium values, ma'am, are actually defined again as center points. So one second, let me just put this back. Yeah, I'll get to this. So what you are talking about is actually called center points. Now, medium values can't be defined in itself. A mid value of 20 and 80 will obviously be 50, I think 50. So, and for 10 and 95, it will be maybe for 45, 55, 55 it will be. So you don't need to define these particularly. You can just check this button, which is called add center points.
Okay.
So what this will do is it will add that point to your design run,
Okay, ठीक है.
the 40 and 55 point. If you don't add it, it does not add. Now, again, the center replicates is the same concept as which I had explained earlier. You can have multiple center point runs for lack of fit tests. And then another thing is axial points. So a normal design, you can have points within the extreme outside of the point and the center of design space. You can have multiple points within that range. So what include axial point does is that it optimally gets those points for you and also adds them in the design run. So checking these two boxes actually increases the design space. But if you want the minimal design space possible, you would like to keep these unchecked. Obviously, keeping this checked will lead in a more robust and more defined model. But and for this example, I will keep them checked. But if you uncheck them, you get lesser runs. And then random seed is obviously predictable randomness. So giving the same random seed number will always generate the same randomized order of experiments. And if you don't give anything, it uses a random number and then your random order will be different almost every time of runs.
Okay.
Then the next thing is linear constraints. Now, linear constraints is an important thing for extreme vertex designs. So what linear constraint is that you would say want CaCO3 to always be less than equal to. So strictly less is not possible, obviously, but you can put CaCO3 is always less than NO2, or maybe always greater than NO2, or it can be equal to NO2.
से value डालनी पड़ती है.
So these are linear constraints you can add, and there are also possibilities of put a linear constraint as NO2 must always be a constant value, that is 45. These are also some constraints you can add to the experiment. These might increase or decrease your runs based on the number of constraints you have put. So a lot of constraints would obviously decrease the amount of runs you have as designed. So this is the concept of linear constraints between, so different, if you have, let's say, more than 3 components, more than 4 components, you can put constraints between each component and say key component 1 should be less than component 2 should be more than component 3. So things like that, you can put linear constraints here. And uh, this would constrain your design to a more specific range. And after you've put in everything in the form looks right for you, you can just simply click on generate design. One second. Yeah. So you can click on you can click on generate design. And what this will do for you is this will generate the design based on whatever the constraints you had given, whatever design options you had set up, and the available factorial and the process variable and component bounds. So within that constraint of the design, it will suggest a number of design runs to you. So once you look at this design, so let's say this is 2080 resolves to 100, 27.5, 72.5 resolve to 100. So everything will equate to the mixture total, which you will have set up. Now, once your design will look absolutely right to you, you can also change design midway if this does not look correct. And then once everything looks right, just save the design and proceed. Same step as all the other module I showed you. So this will lock the design in place. You can see what model terms are there available for analysis. And for a mixture design, you can also see the simplex design plot. So within what constraint and what design, within what simplex these design runs have been put in for greater number of components. This will be a complex design space which will take number of pages. So you are able to see what the simplex design plot is, what experiment configurations you had run under. Then the generated design. Why we have a separate column for generated design is that you can see you can change these generated runs. This will actually show up as deviated if you do so. So if we were to put 21 here instead of 20, so you would actually be able to do something like that. Now, let me just look.
Yeah, that is, you have to change it to 80, 79, otherwise it will not allow.
Yeah. Yes, sir. So that's the so you put in your design space will be put in like your design space is already created. You can also add manual runs like I previously showed, and you can add multiple outcomes of maybe density, viscosity, hardness. So you can have multiple outcome columns. You can save these if you want to come back to them later. So you'll have this space completely to yourself till you perform the experiments. Once you start performing the experiments, again, you can just put in the results the same way you were putting them in previously. So I'll just put in a few results so that we can see the components.
Or you can show something that is existing now.
Yeah, sir. Give me a second. I'll actually show you a better design then. 1 second, sir. So after you have actually put in all the numerous amount of the number of responses that you want. So for the demonstration sake, I've opened the experiment where I had put two responses. So you can see gloss and density here. It's a similar experiment with temperature and pressure with three components. So similar experiment, it had 44 runs. So you can see I've filled in all the response values, which after you have done so, you can actually again click on this new analysis button, or you can just select the number of runs you want to analyze. So again, the same constraint is there that the number of runs that was originally suggested by the design needs to be at least that many need to be selected. So if you add maybe three more runs, you can add those in the uh, analysis, but the number of rows selected must at least be 44. So after you have selected the number of runs, you can simply click you can select the mode of analysis again, which is a manual mode, lets you select what terms you want for the analysis. And we have separate automatic modes as well, forward stepwise, backward stepwise, and bidirectional stepwise. So once you select the mode and the terms, if necessary, you can simply click on Analyze, and this will perform the analysis for the given outputs. So like somebody had previously mentioned about multiple outputs, this is what it looks like. So you can see the analysis report for gloss, and then if you click on density, you can see the analysis report for density. So that is how it would work for both all or any DOE methodology here. You can select which response you are viewing the analysis report for. So you can see the exact runs that were used for the analysis, and some diagnostic values per run to see if any particular run is actually driving the entire analysis or not. So those kind of runs will be flagged. So you can see other diagnostic values here. And you can see the coefficient table. Then the Pareto chart of standardized effects obviously will be different based on which response you have selected to view the analysis results for. So you can view if all the analysis results here. These are the residual diagnostic plots for density. You can again right click and save these images. Then next, you can see the ANOVA table for the given analysis. So the component only, linear, quadratic. So everything will be included in the ANOVA table over here. And next is visualizations. So you will be able to see the response trace graph for visualizations. Again, save these images if you so want. These are held pressure. Previously we had seen I had some components that were process variables that were in this experiment. So if you change the process to a different maybe variable or different value, maybe let's say 65, I want the temperature at, and re-render. This will actually change how the your graph looks like. So you can change the graph and re-render the components as per you want to see the graph at. Same thing in contour plots as well. Again, for a 3 chemical design, z-axis is not relevant. But if you have a 4 chemical or 5 chemical design, z-axis becomes relevant then, and you can change what axis you view the contour plot in. Again, you can change these held temperatures and select the resolution of the contour plot. So higher resolution takes longer time to load, but will give you a more accurate points. These also can be saved again, and you can also click on the image to find out at what point what the value of each chemical is there and what attribute it is showing. And this can be different for different responses. So for if you select the response to be density and re-render the plot, so this will be the plot for density. So same thing here. You can select which plot you want for which response, and what the temperature value and pressure value of, or any factor values you have that are relevant in this case. Then we have a 3D surface plot. again, this only sees the uh, designs, relevant design space. So the shape here, which you can see, is the what the feasible mixture looks like. So the response surface only focuses on that angle. So you can see that is what it will focus on. And this also has the same targeting system. You can zoom in, zoom out, and also you can click on particular values to see what value the response trace plot is showing. It is the same thing. You can change the what response it is being shown for, and also you can change the temperature, pressure values. And we also have an overlaid contour plot. So you can put in the minimum and maximum gloss or density values if you wish to have a particular space in which you want to see the contour plot, overlaid contour, or without putting it also will provide you a result. So this will be the overlaid contour plot. Again, this is the culmination of both contour plots. So you can see when you put a target on the overlaid contour plot, you can see exactly what combination is resulting in which both the values you can see, the gloss and density. And contour plot would only give you one specific value. So these will be all the visualizations available. Next, we also have prediction what if analysis. So similar to what we had seen for screening designs, we can put in some values for
sir.
yes,
Excuse me, sir.
yes,
हाँ
yes,
सर,
ma'am.
अभी जो आप विजुअल रिप्रेजेंटेशंस दिखा रहे थे उसमें कलर कॉम्बिनेशन वगैरह चेंज करने का ऑप्शन होगा? जैसे ये लाइट ग्रे कलर है, तो जब हम इसे कॉपी करेंगे तो बहुत लाइट हो जाता है देखने में। तो कैन वी चेंज दीज
जो
वैल्यूज
values हैं,
हैं, कलर ऑफ दीज वैल्यूज एक्चुअली?
Color of the values, ma'am. Currently, all the
Currently
colors.
color is not there, but resolution थोड़ा बढ़ा के दिखा दो एक बार ना. Resolution
Yes, sir,
लो तो हाई
resolution
कर दो एक बार.
will. Okay, it will take some time to load for a overlaid contour plot. But the thing here, ma'am, is that we are using all the industry standard colors. The colors can't be changed currently.
ओके,
So, better resolution, better resolution of these graphs will, yeah. So, a better is this is the highest resolution possible. So, better resolution will end up in smoother graph points for you, but the colors itself can't be changed.
ओके, अगेन वी कैन कॉपी इट फ्रॉम राइट क्लिकिंग द पिक्चर, है ना?
Yes. You can save the image. This
ओके,
image can be saved.
ओके,
So what was I showing? So we were at prediction, same thing as screening design. Prediction actually allows you to be able to give a particular input, and accordingly you are able to 35 maybe 35, and accordingly you can see what the uh, resultant responses would be like. So let me just enter what is here. So 25, and then temperature was between 40 and 70. So maybe 50 and 400. So once you have put in all the input values, and you can add as many rows as you like, click on predict. I must have put in extra values. 30, okay. 30 this will be. So after you have put in the proper values, you can see the gloss, what the gloss would be at this particular component and process values will be shown along with the 95% CI, 95% CI low and high, 95% PI low and high for gloss. Then same for density, you can see what values it has. And then again, the 95% CI low and high and PI low and high for density. So this will be the case for any number of responses you have. Same thing, but reverse case and optimization analysis. You are actually able to define the specification. So let's say I want my target gloss to be 40.6 and target density to be 6.05. 0.05, and then you can give a lower or higher value. 35, 50, any lower or higher value that seems appropriate to you. And weight and importance can be decided based on if you want gloss to be given importance more, because there might be some cases where your target cannot be reached for both, but if you give something more weight and more importance, target of that will be tried to reach first. So that is how you'll have to define weight and importance. If you keep the same weight and same importance for both, it will be treated as identical. And you can change the goal type to minimize, maximize, and target. Click on target, and then just click the optimize button. Now this will actually provide to you the optimal inputs, the best optimal inputs it found for these particular inputs that particular outputs that you wanted to target. So you can see here 40.6 and 6.05, and the composite desirability is 1. So approximately the exact goal was reached. So you can see up to 10 solutions, up to actually 20 solutions to what solutions would be required to get a target maximized or minimized values of gloss and density as what you have inputted here. So these again, if you want to export it, you can do so by right clicking and exporting it. So this is available, and you can also export the entire analysis section of ANOVA table and a Pareto chart by selecting this download button, export, and clicking on PDF or Excel. So this particular analysis export would be exported to the required format. And again, next we have the same AI feature. If you want to ask anything about the analysis. So this AI feature exists for every module. So you'll be able to again pop these out and compare results with what you are seeing in this Ask AI, and then ask it further questions on any particular responses you find. So that is how this flow will work. So that is for Mixture DOE. Next, Samvit sir.
Yeah, I think this should be enough for a brief introduction about the product.
हेलो सर, मुझे एक और क्वेश्चन है सर। जो आपने हमें ये DOE ज्योमेट्री का जो आईडी पासवर्ड दिया है, मैं उसे ओपन करके देख रही थी। तो जब इसमें मिक्सचर डिजाइन ऑफ एक्सपर्ट ऑन कर रहे हैं तो न्यू एक्सपेरिमेंट का ऑप्शन आ रहा है, फैक्टोरियल में भी आ रहा है, लेकिन स्क्रीनिंग डिजाइन और
एक बार स्क्रीन शेयर करेंगे आप मैम?
एंड रिस्पॉन्स सरफेस मेथोडोलॉजी, तीनों में नहीं आ रहा न्यू एक्सपेरिमेंट का ऑप्शन।
एक बार करेंगे, स्क्रीन शेयर करेंगे एक बार?
सर मैं ट्राई करके देखती हूँ। सर इज इट शेयर्ड?
यस मैम।
स्क्रीन ये देखो सर, यहाँ पे ऑप्शन नहीं है।
अच्छा, आपको राइट्स, एक मिनट, राइट्स असाइन करना पड़ेगा इनको।
और दूसरा भी दिखा दो।
सर और अगर मैं
जस्ट होल्ड करिए।
फैक्टोरियल में है, लेकिन स्क्रीनिंग डिजाइन RSM इसमें नहीं है, तीनों में।
हाँ, एक मिनट हो जाएगा अभी, जस्ट सेकंड। वो इसमें ना परमिशंस असाइन करना पड़ता है।
ओके।
अभी रिफ्रेश करिए मैम एक बार।
आ गया। सर तीनों में आ गया।
आप इसको एक्सप्लोर करिए, है ना?
हाँ
वी आर
सर।
अवेलेबल फॉर एनी काइंड ऑफ क्वेश्चंस यू माइट हैव।
ओके सर।
Okay. Any comments on what you just saw? Have you ever used any other DOE software in the past?
हाँ सर, किया है सर। मिनी
कौन सा
टैब और
software?
चैट इज यूज किया हम लोगों ने।
Okay. How do you feel about this software versus the previous experience?
सर इसका इंटरफेस तो इजी है, इसको यूज करना आसान है। एक के बाद एक के बाद एक ना वो सीरीज में लगी हुई है चीजें नीचे तक,
Okay.
तो
Okay.
इसका यूज तो इजी है। पर वो
सेकेंडली AI फीचर है।
नहीं, ये उनमें भी है, उसमें भी है AI फीचर। इसमें एडवांटेज ये है कि आप कह रहे थे ना कि इंडिविजुअल वैल्यू को आप एनालाइज कर सकते हो डाल के AI में, वो एक बेनिफिशियल फीचर है।
एक वो मैनुअल एडिंग।
हाँ, मैनुअल एडिंग वाला बेनिफिशियल है कि मैनुअल अपनी वैल्यूज ऐड कर सकते हैं। और जो मुझे ड्रॉबैक लगा है वो फोटोग्राफ्स का रिजोल्यूशन है, क्योंकि वो मुझे लाइट लग रही है, क्योंकि जब हम इसे कॉपी पेस्ट करके शीट पे लेकर जाएंगे ना, ये और भी लाइट हो जाएंगी।
और सर कोई भी जनरल जो होता है ना वो
ब्राइट और हाई रेजोल्यूशन पिक्चर्स मांगता है। वो पब्लिकेशन के लिए हमें थोड़ा डिफिकल्टी होगी वहाँ पर।
बस और तो कुछ
बस यही एक दिक्कत है, बाकी ये बहुत अच्छा है।
ओके। आपके पास मिनीटैब था तो फिर आपने क्यों चेंज, अभी वायर
तो
यू
हम
चेंज?
ट्रायल वर्जन्स पे काम करते थे।
ओके ओके ओके, खरीदा नहीं था आपने उसको?
हाँ, खरीदा नहीं था। वो 1 मंथ का ट्रायल वर्जन आता था ना स्टैटिस,
ठीक
और
है,
इसका वो लेके हम काम कर लेते थे।
ठीक है। चलिए, आपका फीडबैक वी हैव नोटेड, है ना? हम एक्सप्लोर करेंगे बाकी सॉफ्टवेयर से कंपेयर करके
हाँ जी।
इसमें क्या इम्प्रूवमेंट कर सकते हैं हम लोग, है ना? आप अपना जो भी कभी भी कोई भी फीडबैक हो तो आप प्लीज़ बताइएगा, है ना? तो वी आर
ठीक है।
हियर फॉर योर सपोर्ट एनी टाइम, है ना?
ओके सर, थैंक यू।
ओके ओके, थैंक यू।
थैंक यू सर।
ओके।